Okay, we've talked about quadratics in the form of y equals ax squared plus bx plus c without really talking about this middle term here. We know that a coefficient changes how wide or narrow the graph is, also whether it opens up or it opens down as a hill or a bowl. We've talked about c. C shifts the graph vertically up and down. Well, what does b do to the graph? Well, b does a combination of things. B can move the graph left and right, but it can also move the graph up and down. And here's how it relates. We know that the vertex is that point at the axis of symmetry right in the middle of our graph. It's either a maximum or a minimum. For a lot of the graphs we've talked about, like y equals 3x squared, we know the vertex is 0, 0. But if we look at something like y equals 2x squared plus 4x, this has a different vertex. And let's go ahead and see what that vertex looks like. So let's make a table of values. And let's start off with some of our standard values. -2, -1, 0, 1, 2. -2 squared is 4 times 2 is 8, plus 4 times -2 is -8. So 8 and -8 give us 0. -1 squared is 1 times 2 is 2, plus -4 is -2, 0 gives us 0, and then we end up with some symmetry here, right? Well, not quite. Look what happens when we plug in 1. X squared, 1 squared is 1 times 2 is 2. 4 times 1 is 4. 2 plus 4 is 6. This is different, right? 2 squared is 4 times 2 is 8 plus 8 is 16. So if we look at our information here, we actually don't have that same sort of symmetry that we've had before around 0. This time our symmetry actually is happening here around -1. See, it goes to 0 and 0. I bet you if we plugged in -3, we'd end up with 6. -4, we'd end up with 16. Let's go ahead and graph this thing. So we have these points. At 0, we have 0. At -1, we have -2. At -2, we have 0. At 1, we have +8 up here, or positive 6. And at -3, we're going to have +6. So notice that our graph this time is shifted over to the left. Our vertex here is -1, -2. But it's not just shifted left, it's also shifted up and down, right? Now it's at -2 rather than at 0. And our axis of symmetry here is x equals -1. So let's look again at the equation that got us here. Y equals 2x squared plus 4x. And how does this all sort of relate? Well, the relationship actually has to do with the ratio of our b coefficient and our a coefficient. Okay, 4 divided by 2 is 2, which is close to what we have here, but it's not quite there yet. The axis of symmetry is actually occurring at -1. So if we take 2 and we multiply by 1/2, we get 1, and if we make that negative, that's our axis of symmetry. So the ratio here is actually the opposite of the b coefficient divided by twice the a coefficient. This will always give you the vertex, x-coordinate of the vertex of your quadratic. All right, so let's test this out. So remember, we're dealing with this standard form And we know that the x value of the vertex is going to be equal to negative b over 2a. So let's see if we can find the vertex of y equals x squared minus 6x plus 4. Well, in this case, b is negative 6. So x equals negative negative 6, or just 6, over 2 times a, which is 2 times 1, which is 2. 6 divided by 2 is 3. So the x value of our vertex is 3. Also, our axis of symmetry is x equals 3. How do we find the y value of our vertex, though? Well, we just have to plug in. Y equals 3 squared minus 6 times 3 plus 4. 3 squared is 9 minus 18 plus 4. 9 minus 18 is negative 9 plus 4 is negative 5. So y equals negative 5. And our vertex, therefore, is 3, negative 5. Okay, so that's how we find the vertex of these graphs. And that's really the whole next section, is just dealing with things with these b coefficients and how we find these various things. Make sure when you're graphing these functions, you are plugging in enough points that you're actually getting the shape. Don't assume that your vertex is 0, 0. For many of these, your vertex is not going to be on the y-axis at all. It's going to be somewhere else. And remember, you can always find the vertex by using your negative b over 2a.